Hello everyone, I am Sakshi Singh from MCA first year, Division A of Vishwakarma University. And today I'll be discussing the Cocomo model from the subject Software Project Management. Cocomo, which stands for Constructive Cost Model. It was developed by Barry Boehm in 1981. Cocomo was created to estimate the cost, effort, and time required to develop software systems. It's one of the earliest algorithmic software cost estimation models. And though newer methods have emerged, Cocomo remains foundational in understanding software estimation practices. Importance of cost estimation. Now, let's talk about why cost estimation matters in software engineering. Proper estimation ensures we can plan and allocate resources effectively. Without it, projects risk delays, budget overruns, or failure altogether. Estimation also builds trust with stakeholders by setting realistic expectations around time, effort, and cost. In short, it's the foundation of project planning and risk management. Types of Cocomo models. An overview. Cocomo comes in three main levels, each offering a different depth of estimation. First, we have basic Cocomo, the simplest model, then intermediate Cocomo, which adds more cost factors, and finally, detailed Cocomo, which goes deep into each phase of development. Each level increases in complexity and accuracy, so the choice depends on project needs and available data. Basic Cocomo. The basic Cocomo model gives a rough estimation of effort and cost based solely on the size of software, measured in KLOC, that's thousands of lines of codes. It uses a simple formula. Effort is equal to A into KLOC to the power B. The constants A and B depends on the type of project, which is categorized as organic, semi-detached or embedded. It's fast and easy to use, but only provides high-level estimation. Intermediate Cocomo. The intermediate Cocomo model builds on the basic one by adding 15 cost drivers such as product complexity, team experience, and tool usage. This allows it to adjust the effort more accurately based on real-world factors. For example, if the team is highly experienced or using powerful tools, the estimated effort may be reduced. It's a great balance between usability and accuracy. Detailed Cocomo. Now we move to the most sophisticated version, Detailed Cocomo. This model breaks the project down into subsystem or modules and evaluates each one separately. It considers the impact of cost drivers at each phase of development, like design, coding, and testing. This model is especially useful for large and complex projects where accuracy is critical. Comparison of Cocomo model. Let's compare all three models briefly. Basic Cocomo is quick and easy but less accurate. Intermediate Cocomo adds cost drivers, improving precision. Detailed Cocomo offers the highest accuracy with phase-specific estimation. The choice depends on project complexity, size, and how much information you have at the start. Limitations of Cocomo model. Despite its usefulness, Cocomo isn't without its limitations. It's based on the waterfall model, so it's less suited to agile or DevOps environment. It requires estimating lines of code early, which is difficult in modern practices. It doesn't account for code reuse, AI tools, or automatic code generation, which are common today. That said, it's a still valuable tool, especially in academic or traditional project settings. Example calculation. Let's look at a quick example using basic Cocomo. Suppose we are developing a 32 KLOC project of organic type. Constants for this type are A is equal to 2.4, B is equal to 1.05, C is equal to 2.5, and D is equal to 0.38. Effort is equal to 2.4 into 32 to the power 1.05 is equal to approx 91.2% per month. Development time equals to 2.5 into 91.2 to the power 0.38 is equals to approx 14.8 months. This simple calculation gives an idea of the scale of effort required early in the planning phase. Summary. To summarize, Cocomo is a well-established method for software cost estimation. It has 3 levels: basic, intermediate, and detailed, each suited to different stages and complexities. While it has limitations in modern context, it remains useful for foundational understanding and in structured environments. Cost estimation, when done properly, can be the difference between project success and failures. References. Here are some key references for those interested in learning more. Barry Boehm's original book, Software Engineering Economics, and Pressman's Software Engineering, A Practitioner's Approach. IEEE articles and modern estimation tools online. Thank you.